Okay, getting started on our seventh data analysis bootcamp class, the workbook today. This class is a really, I think, valuable class in the sense it might not be the most fun that you'll have doing your data sets, but it will get you to the fun part. Getting good with these concepts is really the working with, playing with, manipulating the data to get kind of in the search of the answers that you're looking for. Okay, so it's a really valuable class in that sense. If you don't remember everything, that's fine. It's good to just, remember what's possible and then use this as your reference material while you're slowly getting your fingers to remember maybe quickly. Your fingers remember quite, it only takes a few times of typing these things out, but you have to find the situation to use these. Okay, I'm sure you're doing data analysis, data science every day, but how often do you get to each one of these concepts? And so lots of these things are a little bit more specialized when you need to use them. So we're using different data sets today. So we have the Titanic, the TIPS data set, the Iris data set, the Penguins data set, the Cars data set, the Wine data set. And these are kind of the famous data sets you probably have seen these, at least seen lots of these already. And then the Google stock price and economic features from an economic workflow that I've been collecting these economic features. Okay, and so going through that, and then the first one we had to was the duplicated. Okay, so if you want to check for a duplicate, how many duplicates there are, you just do duplicated parentheses dot sum parentheses gives you one. We know it's one null value, but what we can do is we can use the duplicated, which creates a series of true and false values, a Boolean series, and we can then use the true values. We can't see it here, but wherever this is in row 202, we can select that one row, the one time it's true from the data frame by putting df square brackets df duplicated and sign, and we can get a sense of that. And then I think that'd be really valuable not just to see it, but to inspect which event is happening twice. This is maybe easier to see that this was a mistake, but you could get some situations where it's duplicated, but maybe that is really the data, right? So you just need to be aware. Very rare that that would actually be the true data, but it could be, and so just good to view it and understand the data as a whole. Okay, so identifying null values. So pretty good workflow. Pretty simple workflow. You've probably seen this is null, and then you got to sum this up. The reason that we're summing it up is because what it does is it creates a matrix of true and false values, and by sum by default it's going to be vertically working across the rows, and so by default it's going to go axis equals 0, axis equals 0. Okay, you could change, in all Python or Pandas functions have this ability to control, are we going horizontally or vertically? If you axis 1, it's going to sum up the null values per row. In this situation, it doesn't make sense, but it's something to be aware of. The reason this just kind of instantly works is because we're actually doing it across the x-axis. We're summing up each column to understand if there's any null values. So in this data set, there's no nulls. So perfect, easy peasy. Data type conversions. So what we're doing here is the horsepower column. Did you see there is horsepower? We would expect that this would be a numeric one. You can see horsepower. It looks numeric. It's not showing up that way. Okay, so let's replace it with a null value, and I'm going to change it to a float. And now I can correct that and change the data type. Now it isn't a float. Now I could fill this with df.fill_NA or something like that. But now the thing is I'm going to be able to do mathematics on this because this is now a numeric value, um, not just the value of a string. Because strings are very, I've mentioned this many times, data types are very underlying kind of subtle way we communicate with Python. So we need to make sure that if we wanted to do mathematics on this, you can't do math on a string. So you need to make sure this is now the correct value, and whether or not we wanted to replace that or not, we would need to either do this at either step with that. Okay. Going on to the next one, cleaning some of our strings. Okay. So this was a little bit more tedious in the step, and usually working with strings is a little bit more tedious, but to make it less tedious, we're going to make all of them lower, and I'm going to get rid of any white space they have on the edges, on the outside, not in the middle, but just on the outside edges, just to avoid kind of not seeing those and that causing some issues. Okay, so if you can see the value counts, there's many unique different types of car names in this data set. it would be a lot more valuable if they're all the same car name, and we could understand maybe the correlation in certain data sets, which between the miles per gallon and the weight of the car, but really look at how that portrays between different categories. But when there's almost when there's 300 different categories, it's tough. So what we're going to do is reduce those down to get it to a more workable number. Okay, so what we're doing here is we're going to replace now. So this is actually the step that I did at the end. Okay, so what I did, and we'll get to this, but I found some spelling mistakes that were just one-offs that I needed to correct. So what this is I'm going to say str.replace, and this means I'm going into the string and I'm going to make a change into the string. Okay, I'm going to look from the beginning with anything in between the star and then the star again, dot star, anything until, and then the $sign end of this. Okay, so looking from the beginning with anything between, looking for VW with anything between until the end. Replace that with Volkswagen. Misspelled Volkswagen, replace that, found that anywhere in the string, and replace that with Volkswagen. Find Mazda anywhere in Mazda with an X, replace that with Mazda with a Z. Okay, and so going through correcting those individual spelling mistakes there. You know, so we're getting a lot of warnings here, so I'm going to turn this on warnings.simple filter ignore. This will just, if I were to run this again, it would stop those from happening, so that when I run this next section, we're not going to get a lot of errors as I run this. Okay, so make sure I'm running these as we go through this. And then in this next one here, going to go here, we're going to go Ford, Dodge, Toyota, Chevrolet. And every time I find one of those in this string, I'm going to then replace it with Ford. So I'm going to find Ford in the string, just replace it with Ford. Find Dodge in the string, just replace it with Dodge. So looping through all of those. And now after I do that, you can see here, I get a much reduced number of values. I still found that there's quite a few of these less occurring vehicles, so I moved these ones and I moved them into just the other category. So I'm gonna find any value with Audi in it and replace it with other, any value with pig what, and replace that with other, and so on. After I do that, you can see here much more reduced. I have lots in the other category, but now I could do interesting kind of analysis on just this simply reduced. And look for kind of subtle differences in the manufacture of these cars. Okay, so kind of interesting, a little bit tedious to do that, but looking at the string usually is a little tedious. Looking at truncating some outliers. So I wanted to show with this one the effect of outliers can have on our data set. So what we're going to do is we're going to look at a couple different columns here. So we'll come back to this one in a second. So what we did first is I looked through all of the distributions here and just found some good columns that would make sense with outliers. There's quite a few in the wines data set. So ones I focused on was sulfates. You can see the outliers right here, and then alcohol. Not so extreme, but there's a couple outliers over here. Okay, so let's look at what the correlation is between sulfates and alcohol. So we got sulfates and alcohol right here. So 0.09. Not strong or anything like that, but just highlighting 0.09, right? So let's see how much this changes as we go through this. Okay, so we'll clip this. I'm gonna just use a very simple clip upper, clipping it down to 1.1, removing not maybe even to the IRQ range, but moving this tail over here, a big portion of this tail. On alcohol, clip this little one right here all the way to this 113.5 right here, move everything a little bit closer here. Okay, so what happens is after I do this, I'm going to look at plotting the diverging palette again. And so the other one right here, we saw alcohol and sulfates, was this one right here, was 0.09. It's 0.14 now. So that's greater than a 50% increase in the correlation. It was because it was a small number, but if you have a 5-point or even potentially more in some cases, change in the correlation because of your outliers, and that's just changing the outliers, right? We're just making them less extreme and kind of emphasized where the actual, so there actually is a little bit more of a almost moderate, a little bit more weaker correlation than non-existent to start with. Okay, and so really interesting the amount of it changing 5 points. You know, 50% is a big change, but even changing by 5 points, even a higher correlation, but a moderate correlation, you know, you could be changing it by 50% and or even 10% of the value. If you can change 50.5 correlation by 5, I mean, you can really start to manipulate your answers and again, not manipulate in the sense you want to get a truer answer. So you want to understand how much it can manipulate so you can more readily go in and manage it how you think is appropriate for your business situation. Okay. So let's get into some data aggregating. Okay, so looking at the way we take it is very simple. And as I mentioned, the Pandas functions are working across the columns. So we're doing mean here, working across the column max. This is getting, and we have actually some string values in here because it works on strings. So you get the max string, the last one in the string. Some it does actually works on strings as well because we're just going to add them all together. This string plus this string plus this string. But you can see the numeric values it's adding up, and the median again only works on numeric values. We can aggregate those in some other ways. So using those functions, median, min, max, we can do things like group by. And if you do the group by object, this is where it's the split. So it's not been recombined, it's not aggregated and then combined. And so we can't really see it yet. It's kind of floating around sub data frames for each class at that point. And you can only really see the location, the place in memory it is. So not super helpful. Okay, so what we can do is we can find the group dot mean, and once you apply this aggregation, it aggregates it and then combines it, and we're able to see now the average by the class for each one of the columns. Okay. You can look at this in our P class right here, and you can start to get a sense of where these values are changing, like how much. You can see P class has 3 values, much bigger average here, and start to make some real comparisons between this. If you wanted to get something between the median and the mean, see 2 different values, you get the median age right here using the ag function. And we give dictionary column name, median, column name, mean. So I'm getting the average ticket for the median age. Okay. We can also make a custom aggregation function. So I'm going to get the range. So this custom ag function is going to be the range of my data. Okay. And I'm going to say age. I want to get the range of my age by the average of my age. Okay. You can see it works well. A little bit more specialized when you really want to use that, truthfully, but hey, it's handy that you can do that. Okay. Crosstab is another way to do it. Remember, grouping by is grouping by a category. Crosstab is going to kind of subsection your data in 2 different directions. Okay, so by default, it's going to do the count. So we're doing survived and P class, and just when those cross section right here. So most of the times is 1 and 1 and 3 and 0. Okay, so you can see 3 really survived a lot better if you paid for more money in your stay. Okay, or you were less likely to stay in proportion really here. Right here, when you were the best P class, number 1, you definitely survived. Well, more likely to survive at least. Compared to if you didn't pay for it, a good class. Okay. The cross tab here, then, so it does the count. And so here what it's doing is the count again, but I'm going to say, actually put the values of the fare and take the average of the fare in one of those cross sections. So survived class 3, and you can see really the survived class, one of the ones that also paid the most for their class, paid the most either. So they're not just the higher up, they were the very high up people, the very rich people. Okay, and you can even sum up and seeing, although more money was on average was spent by these people, more money was spent in total by the poorer people, the less fortunate people, in the who did not survive. Okay, lots of money there. Okay, and only a very small portion of those actually ended up being saved, in in terms of the dollar number. Cross tab here, and it's kind of good just to be if you want to put that in a matrix right here or a heat map. You can see that the scientific notation makes it it's not super complicated to read. It just makes it a little bit more, I don't know, you have to think a little bit more, right? So with that, it's good to change the formatting. You go format equals 0.2 right here and just change that format. Again, making it look a little bit neater and cleaner as you're putting in that cross tab, the averages. Okay. We could also do combining of data frames. So just like we had these few series, we can combine those series and we'll go pd.concat series 1, series 2, series min, max, and I'm going to combine those. If I don't combine them, if I don't change the column names here, you won't be able to see it's 0, 1, 2, 3 gets created. If I change the column names, it makes it a little bit easier to follow here. and I just use the exact same size list of the actual number of columns I have or features I have in my data set. So notice that when I didn't have some of the min and max worked on the strings, when I had those, when I didn't have those values in min and median, I just got created null values for those index values, those where the index location took place. Okay, and then where they marry up. So it does it kind of intelligently. It really is just sticking our data together, not intelligently in any real sense, but just sticking them together, but keeping track of it in a lot of sense. So it's really handy to use in a loop. Okay. So, and we're sticking the concat shape 2, and then after I, and so if I had a data set where I wanted to combine, so I had the original Titanic and the second one that I imported from the test set, I could stick those data frames together and take a peek at those and then see here. You'll see though, when I do the is null value on this dot is null dot sum, I didn't have in the test data set, I didn't have the as many targets in that section, so I'd have a lot more null values in that survived data set just because of the test values, but it married up the rest of them where I had values. Okay. Merging and joining. Okay, so merge is good when we want to join on something. This makes the most sense when you have a date and you want to bring things in to be appearing on the same date. And that's, important in lots of situations when you want to marry things up on this. And merge would be also bringing data, maybe customer details into a transaction database. So you plot each row then with, it's this age, this, time, this, location. But you don't really keep that in the transaction database because it's just be a lot of extra data that you don't need. Repeated every time for those operations. Okay, so instead we're going to bring things and join them on time. I'm changing the Google data frames to the date column. I'm going to marry it up on the date. So I'm just making the format is going to be 4 digits, 2 digits, 2 digits. It's capital, small, small. I do that on the date time version of this column. I'm going to go .dt .string. So I'm kind of doing a lot of things at one time. So string f time, string from time, and doing it there. Okay, so I convert it to a date time so that I can convert it back into a string in the correct format. That way then I can merge df.merge, which my other data frame was already in this format, and I can merge the Google with the economic features that I collected, and it's how inner on the right date time, and you can kind of change those around. I wanted to marry up where I would have, so it'd be on the economic data set that I'm going to merge on all those columns that I have that one on. I can merge on the right on the date index here. Okay, and so marrying up how I'm going to, which is the column name and how I'm going to merge these, Google and DF. So one is marrying up on this one, and then the other one is right on date and left on date, or sorry, right on date index and left on date index here. Okay. And so doing this again, this creates a data function. And so here now I'm doing a left join, and I'm going to save the data frame. Once I save this, then I'll actually have access to this data frame. So I can do then, if I wanted to see, I'm going to drop a couple columns right here, do the correlation matrix, and you can already start to see some things on the weekly, which is kind of interesting. There's a lot more cleaning up you'd have to do to get this to work well, but you can start to see things like which is closing price right here. The Bloomberg's confidence has a 63% with the closing price of Google stock, 73% with average weekly hours. Chicago PMI seems to have no correlation at all, which is very interesting. To get access to all the other features, you have to go through the cleaning section of this, cleaning these up, and these strings up to into words, because they have lots of symbols attached to them. So it can be with the skills that you learned up above, you can go through and edit that and see what has a correlation with the Google stock price. Okay. Handling features. So one hot encoding here now, super duper easy. I have the tips data set here. I have a couple columns here. I'm going to change the sex, smoker, day, and time. Those are columns. So time is just, day of the week. Sunday is just Saturday and Sunday. And what we'll do is a one hot encode those. And that will create another column then for sex, female, sex, male, smoker, no, smoker, yes. And then you can start to do interesting things and start to understand if there's a relationship between things. So female, we could start to understand, not really a strong relationship or anything, but females tended to come in more on Thursdays and less on Sundays. Interesting, right? So you kind of start to give you some insights into what's really important in your data set. And you can see here really just giving you the sense of, now you can use your categories in testing, when it's true, how is it related to other points in my data frame. Okay. You can see here, when the time is the dinner, it is usually on a Saturday more than half the time. And then when it's lunchtime, it is much less, it is more often on a Sunday. So it's less often happening on a Sunday. Okay. So it's interesting that you can kind of start to see those interrelationships between the categories. Shifting is super duper easy. The way that we're going to do this is do the correlation, do close one from close to date. We're just going to shift this by one. That's going to bring something down and into the future. So we're moving the past into the present. And I'm going to multiply this by 100 to get kind of more of an interesting. We have to make our data set stationary before. So I'm going to do the percentage change so that I can explore these correlations. Okay, so I'm going to do this first, and then what I'm going to do is, in a loop, I'm going to go through 1 to 20 days. I'm going to look at the correlation. I'm going to shift my correlation by the same amount. And then what I'm going to do when I plot this, I'm just going to look at the actual correlation changes. Okay. And so what's kind of interesting about this is you can see here, I'm just looking at the last days I did in my correlation. So of the amount of days that I correlated, that I did this shift on, and we can see here then the last day is from day 1 shift, day 2 shift, day 3 shift, and understanding then the correlation between these data sets, right? And so understanding here between day 1 and day 12, you're getting a data set or correlation of this. And what's interesting is there's this higher correlation that runs kind of, I guess you would say, weekly between these data sets. There's an interesting relationship that's flowing through the data. Okay. And we're seeing this because we're doing a whole bunch of correlations all together quickly. Okay. So we can also do some reshapes of our data, and Pandas makes it really easy to do. So going from our long form to wide form first, and vice versa. Okay, which would be a melt. Okay. So the first time, what we're going to do is we're going to focus making it into a wide data set. So we have our penguins data set here. Making it into wide, we're going to say our index now is going to be our species. Column is going to be the island. Values are going to be the values inside this are going to be our body mass, and then we're going to aggregate it. So it's using a pivot table, right? It looks very similar to the cross tab as well. Okay, and so here we get a wide data set, and now going from wide to long. So we're going to take this data set as it is. We're going to go species along the side. So we're going to make it all one column there. We're going to build length and build depth. Now it's going to have its value to identify whether the build millimeter is by the depth or the length. Okay, so it's basically making it longer, right? So this would work well if I wanted to put this into a seaborn plot, because now I could use this just to change the hue by the dimension, and it would change the color. So it can work in some plotting techniques as well. And you can see here really the dimension equally balanced, one for each of those. Okay. So thank you so much for joining me in this in the 7th class, almost all the way through now of our data analysis bootcamp. Not so bad, huh? I'll see you in the next class for Plotly, which has some really cool plots in that. Okay, see you there.